Hello and welcome to the EMA Work Designer layout tutorial. In this part, we will take a look at the basics of the EMA object management. You will learn how to work with the object tree, how to add objects, and what object hierarchies are. As an example, I brought you our training scenario. At first, we want to take a look at the Objects tab. Here you can find an overview of all objects in the scenario. In the upper area, there are different command buttons. Below the command buttons, you can find the object tree, in which you can see all the objects that are in the scenario. To select an object, you can either select the object in the 3D view or click on the object in the object tree. The selected object is highlighted orange in the object tree. On the right side of the Object tab, the specific parameters of the object can be adjusted. These parameters change depending on which object is selected. In this case, I have selected the rack and can adjust, for example, the length here from 800 to 1000. Next, we will look at how to add objects. When adding objects, they are automatically loaded into the origin of the scene. If you already know where the object belongs, you can specify an alternative insertion route. For this purpose, I choose the structure node Basics of Object Management. To set it as an alternative insertion route, I right-click on the object, which opens the context menu. And under the point Creation, I select the function Set Object as Alternative Insertion Route. Here above, next to the command buttons, you can see that the new alternative insertion route is set. This is valid as long as the check mark is set. If the object should be no longer the alternative insertion route, the check mark can be removed or a new alternative insertion route can be set. Newly loaded objects are then loaded in the coordinate origin of the alternative insertion route and are assigned to it in the object tree. To add objects to the scene, there are three different ways: adding external objects, loading human models, or adding library objects. In the library, you will find numerous objects such as tools, furnishings, robots, and much more. There are currently more than 500 objects in the library, and with each update, more will be added. In the library, you can search for objects or click through the categories. At first, I want to add a container. Therefore, I type the name in the search bar. On the right, you can see the 3D preview of the selected object. And below, there are different parameters that can be adjusted. To load the object, you can either double-click on the name or use the button Add Objects below. Now we can see that the container has been inserted under the alternative insertion route in the object structure, and it's loaded in the 3D view. The second library object I want to add here is a Euro palette. For this, I go to the categories, Transport and Logistics, and Transport Equipment. I have now loaded two objects from the library, and they are located in the object tree under the structure node Basics of Object Management. And here they are in the 3D view. You can also load external objects by clicking on the button top left and selecting a saved geometry file to load. For example, I will load this ASM gearbox file now. Which file formats you can add depends on the current license you're using. The formats you can load with your license are listed in the drop-down menu at the bottom right. In general, EMA is supporting many different 3D formats. For example, a lot of standard formats like STEP and JT, and also some advanced formats like CATPart, which you can find in this overview. Then you can choose whether to load the external object with its structure or as a single object, if you just need the object in total. In this case, we don't need the structure and load it as a single object. Next, you can change some object properties. Or, if everything fits, the default settings can be used. The last thing we want to do is to load a human model. For this, we click on the middle button and open the Human Model Configurator. Here you can set various parameters. For example, you can choose between male and female and set the basic body posture. If you want to see what dimensions the human model has, the dimensions can be displayed under Body Measurement Details. The two human models are standardized according to the norm. Furthermore, the phenotype and documentation parameters can be set. I will add a male human model here by clicking on the Add Human Model button. I have now loaded a total of 4 objects: a palette and a container from the library, a gearbox as an external file, and a human model using the Human Model Configurator. All objects have appeared in the coordinate origin of the alternative insertion route and have been assigned to the alternative insertion route in the structure. In the next step, we want to structure our added objects. There are 2 different ways of structuring objects in EMA. One is the organizational structuring, for example, to summarize all objects of the material supply or all product data. And the second type is the structuring of physically dependent objects. As a user, you can build a structure as follows. The container should be assigned to the palette and therefore also be moved together with the palette. To do this, I arrange the container on the palette and drag and drop it below the palette in the object tree. Here a black line appears to help structuring and to indicate the current insertion position. The gearbox is supposed to belong inside the container. So I arrange it inside of the container and drag it under the container in the object tree. If the new parent object already has child objects, it's necessary to expand the substructure of the object, because otherwise it won't be possible to put the object under the new parent. Therefore, we can use these small arrows, and I will open the substructure of the palette again to place the gearbox below. Now we have created a simple hierarchy in form of a parent-child relationship between the objects. It's called like that because the higher level objects are referred to as parent objects and the lower level objects are referred to as child objects. In our example, the palette is the parent object, and if I move it, the child objects are moved with it. Children like the gearbox, on the other hand, can be moved separately. In other words, the child is always dependent on the parent, but the parent object is never dependent on the child. This applies on the one hand to the physical position in 3D space, but also to various object properties. A few more tips for structuring physically dependent objects in EMA. When structuring objects, it's helpful to orient to the black lines, which indicate where the object will be placed, and assist in understanding the structure. And depending on whether the object is intended or not, shows in which hierarchy level it's located. The last thing to do here is the organizational structuring. For example, the racks and the Euro palette are part of the material supply. Therefore, I use the multi-selection function by holding down the Control key and select them all. Then I add a structure node by a click on that command button. In this case, the structure node will be added directly under our alternative insertion route. Or you could choose a different parent object by selecting Change Root Object. In this case, the structure node should be placed under the alternative insertion route. That's why I click on Continue. Now you can rename the new structure node, for example by clicking in the top right text field. And if I want to add objects to that new structure node afterwards, I can drag and drop them underneath in the object tree. For example, this other Euro palette also belongs to the new structure node material supply. By the way, the newly created structure node is only clickable in the object tree, because it's an object with no 3D data. At last, we will take a look at the different functions of the object tree for managing objects. The first symbol describes the type of the concerning object. For example, the rack symbol represents the rack. The second symbol is the object lock. If the lock is activated for an object, it can't be moved or deleted, and no child objects can be added. Be careful not to confuse this with the third icon that stands for the structure lock, which means the child objects are no longer individually selectable. And if you click on a child, you will automatically select the parent object. In this case, the palette. By a click on the classes icon, objects can be shown or hidden. So if I hide the parent object Euro palette here, all child objects are hidden as well. With the last symbol, objects can be marked as collision objects. So if you see the red wall in front of the mannequin, the collision detection is active. Without the red wall, it's inactive. After the symbols comes the name of the object. In brackets, there is the object type, like container, which is related to the object symbol. After that, there is the unique object ID, which is only assigned once in the scenario. To edit an object, you can double-click on it. Then you can change the name of the object and also its color. So I'll give that container another color now. As you can see, the change also applies for the child object, the gearbox. On the right, there are two empty text fields for your own comments. And you can change the color of the comment line too. This option only colors the line in the object tree and does not affect the color in 3D space. You can also display objects as a list instead of a tree by clicking on the drop-down menu above and choose Show as List. Here you can sort the objects by the individual columns or use the filter function on the right side, for example, to filter by rags. If you look for a specific object, especially in bigger scenarios, you can search for it by a click on the lens. For example, I will search for the pellets in the scene now, therefore type in the name. And now the different results are highlighted and I can click through them. With that, we come to the end of this part. Thank you for watching this tutorial. See you next time.